All right, here's my area. Just got my sheet of paper. Nothing under there. I'm gonna prop my stuff up on here. Here's everything around. Nothing around here. All right. So today I'm going to solve the charging equation using differential equations. Then using loop rule, so we can just start off there. So we'll go loop rule. We know that V minus VR minus VC equals 0, right? And the first kind of step that we would do is replace VR and VC with their respective equations. So we have V minus IR minus Q over C equals 0. And then we know that current is just equal to the rate of change of the charge over time. So we can write I as dq over dt, right? And plug that into the equation. So we have V minus dq over dt R minus Q over C equals 0. So then we can just kind of clean this up. So we know, so we'll rewrite it, rearrange some stuff. dq over dt R equals V minus Q over C. You can even take that a little further. dq over dt equals V over R minus Q over RC. And then, so basically we're going to want to split these variables so that the differential equation can be solved, right? So that kind of leaves us with dq over CV minus Q. And that would equal dt over RC. That's kind of where I'm at this point. And then we're going to want to take the integral on both sides of this equation, right? So integrate both sides. We'll focus on the left side first. So the left side, when you integrate, leaves us with negative natural log of CV minus Q. And then that would equal to T over RC on the right side plus K. Hey. And then, so at this point we want to solve for Q, right? So that kind of leaves us with Q equals CV times 1 minus E to the T over RC. Right, and that's kind of our charge equation there. So we then know oh my God, my cat's going crazy. Yeah, so then we know that Now we don't know that the charge voltage equals Q over C, right? Plug that in, and then we get VC equals V times 1 minus E to the T over RC. Thank you.